Let's start recording. Okay, good evening to everyone. Welcome back to data visualization course. It's week 18, lesson 2, advanced time series and time series statistics coding dojo. Today's agenda is announcements and assignments. Heads up, workaround for a tick formatting issue. There you may face this issue using matplotlib. I will tell you if you found this issue, how you can fix that. Recap of last class and continue the last lesson code along, which we were doing. 2-3 paragraphs were left. We will continue today. Time series calculations and statistics. Under this, we will cover up calculations, comparing, normalizing values, and rolling statistics, feature engineering, and answer stakeholder questions. Announcements. If you stuck anywhere, you can ping me anytime on the Discord, and you can also email me if you need any help. The recommendation today before the next lesson, please install the public desktop Tableau tonight or by tomorrow. In case you need a help, you can ping me during for the installation if you're stuck somewhere. So instructions are here. If you click on this link, you can find the instruction how you need to download this from the website and how you can register on this and installation, and here you go. It's very easy and simple steps you need to follow for Tableau, because next week we are going to start the Tableau. Your required core assignments. This is your core resampling date time data for this week, preparing time series from white form data. This is from your this week, and core project 4 part 1. This is we are going to cover up today. Before starting over today's lesson, so here I would like to share this heads up with all of you. You may found this issues formatting dates. In this, when you are like using this axis TS plot, this is data frame, axis set major locator year location. This is just an example. You may see here on the x-axis, the dates or years will not come. It will come like this way. Maybe it will start from 1971 and it shows like this. It will not complete the years. If you want to fix this, what you need to do? You need to replace this piece of code, this one, with these two lines. First, you need to declare the figure axis, and then you need to plot the subplots first, and then axis plot ts.index, ts.values. So this will fix this issue if you found it during your assignments and when you are doing the practice in case. So this is very important. If you found if still it is not fixed at your end after following these instructions, please feel free to ping anytime on the Discord. Any questions about this? All right. Okay. So in the previous class, what we have covered? Overview of preparing time series. So this is which steps will come after this first step. Convert the dates and times into a single column if needed. After this, which step you will follow? Anyone? You can also type in the chat. Yes, correct. Great, Scotty. What will be the third step? Yes, Ahmed. Great. Yes. So first you will convert the date and times to a single column if required. Not, it is not required every time. Convert the date time column into data type and then set the date time index. After that, you can resample the time series data as per your requirement using frequency and then impute the null values. So these all are the important steps when you are doing the analysis of the time series data. So this is what we have discussed in the last class, types of time series. This is a regular one when your every event is occurring at a regular interval of a time in a continuation. And irregular or events mean it is happening when it like at a some time, not regular interval. So let's start. So today's learning objective is after this lesson, you will be able to calculate the time series statistics, apply the feature engineering for time series, aggregate the time series using parts of date, and calculate the seasonality of the time series. Types of time series calculation. So there are two types like comparison when you or changing in a value. Rolling statistics, this is another type of your statistics calculation for time series data. In this comparison, these four most common methods come up. This is the difference method. This is you use when you want to stabilize the mean of the time series data. As you have seen, there is a like regular time interval or irregular time series data you have seen different like the pattern of the data. But when you want to remove that, you want to focus on how it is occurring on the specific part, then you can remove those and focus on the some part of the time series data. Then we use the difference method. How you can use, how it look like, we will discuss in upcoming slide. PCT change is just like the difference method. The difference is only now your values will come in the form of percentage instead of the normal value. And CumSum we use when you want to see the total data over the time period. Then you use in those cases. Manual change versus specific date. This is given on LP, but we will also discuss today how you can use this. If we're talking about the rolling statistics, there is a like using your rolling X. This is a feature and rolling X mean. Rolling means it is based on the window size of your data set, of your like pattern of your season. You will focus on the some part of this. This is very useful when you want to look at the trends, patterns, seasonality of the time series data for the long term. And this is for the standard deviation. Now we will move ahead. First, we will discuss about the comparing values. Now look at this data set. If you remember, we have used this S&P 500 data in the last lesson. This is your data set and this is your time series index and these are the values. This is for the ask close value. Now look at this. On this data set, you can see the data over yearly and monthly as well, right? 3 months, quarterly we can say, right? Here you can see it is going up and down, right? It's not like consistent in each year. This is not showing any right now specific pattern. If you look at the high peak, this is coming in this month in the year 2020 here in the April. So now if you want to look for the stable like the over the time, how the pattern is going on in these months over the year, what you will do? Here this is not clear, then what we will do? We can use here the difference method. What it will convert the values to the change in value between the intervals. Now look how you can use that. I have declared here delta underscore TS. This is a new, like your data frame. We will apply this method difference on the entire data set. And then this is your result. How it calculate your value for the difference? If you look at the first day, 2018 or 102, it is showing now, because difference method works based on the subtract the current value from the previous value. Current value from the previous value. It will subtract like this way. So when it is start applying the difference method, it will subtract the first value from itself because there is a no value before this. That's why it will come NaN. And after that, it will continue. Now, if you look at this graph clear here, you can see it is stabilized the mean of the time series data. You can see this is a 0, right? And here the trend is showing, the data is showing. This seems to be stable. And if you want to see the high peak, this is showing here. So this is very clear now. You can see the trend over the time by removing the seasonality, trends, patterns, right, from the original data. It is more clear here, right? At which, like in which month, in which year, this is occurring at a high level. So this is why we use the difference method for calculations to change in a value between the intervals. Any questions about it? Yay. Now we will move ahead with the next method, that is cumulative sum. This is very useful. This is useful when you want to see the whole data over the time. And in this, how you can use that? I am taking the same data set on which we have applied the difference method. What I will do, I will apply the sum on this. It will take the sum of the whole data. How the method works on this? It will do this is 0, well, this is nothing. It will do the addition in the previous value. 42, this value plus this, and then give you this result. And then plus again in this value, then give you the next result like this. This is how your sum work in time series. Now you can see here, your trend and seasonality come back into the original shape of the graph here. If we compare here, if we go back in the first, you can see this is the same trend and seasonality you can see. And again, it's the same here. But with the removal of your trend and seasonality, because the mean is still stabilized here. So this is how we use a sum and how it works, right? If I give you a one more example where the sum is very useful, we can take an example of the COVID data set. If we want to see the whole data, how many COVID patients are there over the total COVID patients over the time, then you can use this method on this data set. Any questions about it? Okay. So now we will talk about the third method. Earlier we talked about the difference method, sum. Now we will talk about the percentage change. That is to convert overall value to percent change in value between intervals. This will work same like your difference method. The only difference is here we will multiply by here 100 using your apply this method PCT underscore change. This is inbuilt method again. And then you will see the values like the events occurring over the time in the form of percentage instead of discount. So this is useful at that time. Sometimes you required it if you want to show the how much percentage of the occurring of the event over the time at that time, this method is useful if you want to use it. Rest, your results are same because we have applied the difference method. This is, we can clearly see the trends here, right? If you notice here, it is not come back into the original data set, right? This is stabilize the mean here. We can clearly see the high peak value here. Any questions still so far? Okay, if something come up in your mind, please feel free to ask. Okay, normalize to a specific date and value. Can anybody tell me why we normalize the data? Anyone? You all know the answer. If your data set contains the values at different unit levels, right? We need to normalize it, right? To get a better results. So in this,
in order to analyze it, right?
yes, good. And to normalize to change in values versus specific date value, how you can do that in time series. Now to save the value to normalize that time series, subtract the value from entire data set. So here I'm taking just one example. I want to normalize the value since from this value. This is your 2nd of January 2018. So now how we will do that? We will take here whole data set dot location and we are passing the date. So we will get the value from here, right? At this location on this date. Now how we change it? We will subtract this value from the entire data set. So every value of your time series data set will become at the same scale and it will normalize your data, right? So this is how like it works and why you need to use it. As I have told you, if your values data set in the time series on the different scales, in that case you can do it. It is also like mentioned examples on the LP as well. This is a manual. We are doing it manually, this thing, because we are specifying the date from which date I want to normalize the time series data set. Here you can see here, this is coming 0, right? Why? Because the first value will subtract from itself. That's why it will become 0 here. Any questions about it? Okay, so now this is like you can also normalize in the form of percentage as well. Like we did the difference, we did the percent underscore change. Here, if you want to show the results here in the form of percentage, you can also do that. We will do the same thing. We will subtracting the normalized date from the entire data set, and then we can divide the from where you want to change since date divided by value for normalization multiply by 100. So then it will give you the result in the form of percentage. So this is your choice. According to your requirement, you can do that. According to the business problem and according to your requirement, which is you want to show to the stakeholder. Any questions? Okay. So now till so far we have discussed about the calculation methods. What were those? Those were your difference method, PCT underscore change, percentage change. And then we have discussed about the consum. After that, we have discussed about how you can normalize the data manually in the form of count, in the form of percentage. Now we will talk about the rolling statistics. This is very useful method, very, very useful, often used in real time. So now look at this. Earlier, we see the data set like this. To get a moving average, you use the whole data set dot rolling of your x dot mean. So it will take the mean of the values which you will define inside the x. Okay. So good way to reduce the noise in its visualization. This means if you want to remove the noise from your time series data set. Look at this data and now method. Calculate the 5-day moving average. We also call it window moving average because we are looking at the specific time period of the to see the trends patterns over the specific time period clearly. Look at this. This is your data set rolling. We are calculating the 5-day moving average here. Dot mean. So what it will do? It will start from this date taking the moving average mean of the 5 days, including this date. So it will come here NANN these fives when taking the average because it will start because we are asking for the 5-day average. So it will give you the result on the 5th day. Okay, and then so on. Now look at this graph. The blue line corresponding to original and orange corresponding to rolling mean. On the left side here, if you look at the original data, you can see this one, little spikes here, right? It's a like this means this is the noise in your data set, right? If you look at now rolling mean of over the data set, it is occurring parallel to this and you can see it avoiding the noise, right? You can clearly see the pattern and the seasonality over the time. So that's why this is very helpful. This is very, very helpful in long term. Like if you want to see, you want to tell the stakeholder what is going to be happen in the future, right? You want to clearly show them the trends which is occurring over the time, then you can use this method. If it is not, you are not sure in the like normal time series data. At that time, you can apply this. So this is, you can decide generally 5 or 7 days window size we take. Generally. Like we can also connect here the COVID example again. Because we had a lot of data and if you want to forecast, right, the COVID cases, what you will do? We can't take the like last 3 months data like collection, then we are going to forecast. You never know what was happening in the, if even you know that we are not sure about the trend and patterns over the 3 months past, right? It is good idea to use this rolling mean average, taking the 7 days or 5 days trend clearly, see the data results, and then you can forecast the result of the COVID. So this is how you can use this. Any questions about it? Does it make sense? Please raise your hand if it makes sense. Okay, good. Thank you. Okay. Now we were talking about in the previous slide the mean. You were taking the mean of the data over the window size, the days you want to see the trends over the time. Now, now we will talk about the standard deviation. This is your choice if you want to do it. It is useful. It will show the changes in its moving average. How? You can use rolling 5 days dot standard deviation method. Now the blue line is your moving average and green shadow is your standard deviation of moving average. What is the advantage of this? This is advantage of this thing is that we can see the trend as well clearly, right? But we can see the hair spikes again, right? It will give you the range of the data or the noise of the data it is showing you, right? How much data was here or event was occurring at this point, right? So you can see the both things here. So this is the plus point of standard deviation. If you want to show or you want to see and show to the stakeholder as well. This is the only useful in that case. Because in the previous year, you can see the original data was like this, right? But when you applied the rolling mean, it removed that noise. But here in the standard deviation, it is showing you the some noise here at this point, right? For the moving average. So at this point, you can use this is again, I will say according to requirement. This is not mandatory at all. You need to apply the all methods. It depends upon your requirement. When you want to apply which method. Okay. So now till so far we have discussed about the statistics of the time series. Now we will talk about the feature engineering. You already did some of the things. Here first we will talk about the extract parts of the data as a feature, right? Like if you have a date and time, you are not interested in the full, like maybe the full date, you are only interested in the year, month name, day, and hour. So these are the attributes which you can use or extract dt dot year. Dt is your, can anybody tell me what is dt here?
Date time?
Yes, it's an instance of your date time, right? So this is inbuilt, okay? So this is how, if this is a year, how you can get it. This is your, like the data frame, data set, date time dot dt dot year. You cannot say direct here dot year, okay? Then dt dot month, if you want to take the month, it will show you the numeric one. Month name, if you want to extract the month name, not the numeric value. Day, again, it will show the numeric value. Day name, name of the month, hour, and seconds. So these are the methods you can use to extract the part of your date time feature as per your requirement. Now let's come here. This is again, I will say, used most of the time. Very useful method for the feature engineering in time series. Calculate decades and centuries. Calculate the decade from the year, subtracting the remainder after divided by 10. How you can do that? Sorry. We will create this one column. This is your year column. If you want to get the decade, you will subtract the year again, but modulo of 10, right? So what does it mean? What value it will give? This percentage sign? This one? This will give you the remainder, right? That you will subtract from your year. So here this is year. When you divided it by 10, it will give you this remainder. Then you will subtract the remainder from the year when you, if you want to calculate the decades or centuries. This is very useful method and used many time in real time as well. The next is how you are going to answering the stakeholder questions. To answer the time series related question, we will often need to keep two forms of our data. if you are visualizing the time series data to the stakeholder, what you need to do, a true time with the date time index with the specific frequency, right? So what does it mean? It means you need to show the data to the stakeholder based on specific frequency. If I am asking you, like, can you show me the COVID cases over monthly, over daily cases, maybe on quarterly? So this is the like frequency you need to set, right? And second thing is a tabular data frame with the engineering features. Engineering features, maybe he is only interested to see on which date most of the COVID cases have occurred, in which month, right? That is a specific part of the date he want to see. So that is called tabular data frame. When we are talking about the with the engineering features, you need to separate that, extract that part. And questions about changes over a time usually require the time series data. This is we know. Questions about parts of the date or how common particular group or event type is usually require the tabular data frame. This is which we have discussed a few seconds ago. Like in the tabular data frame, you need to extract the part on which date, in which month, or maybe if you are like looking at the analysis of the hourly, minute, like the stock market prices, if we talk about on daily basis, right? So in that form, it should be come under the tabular data frame. Okay. So this is how to answering the stakeholder questions. Any questions still so far? Okay. So combining time series data is very like useful, right? How if maybe you want to, if we take an example here, getting the weather data corresponding to sports game dates, right? So if you want to get the weather data corresponding to sport games date, maybe you want to go to see any game which is going to happen in the future, you can check the temperature. So this is like combining with two things, right? Or based on the time series, on which date, in which month, right? What will be the temperature, right? If this event is occurring on that date. So this is the beauty of your time series data, how we can connect it. Getting holiday information for crimes, right? So these are the like beautiful things about the time series data. This is easy to look up for the things if you get a time series data with the data set. Now we will talk about the seasonality. This is another like type of your time series. Here we go. If we are talking about the seasonality, it doesn't mean it is going to be happen in your each time series data. This is not the case. It sometimes occur, it sometimes doesn't occur. Okay. So sometimes time series have a seasonal pattern that increase and decrease over time repeatedly. So there is a like difference. If you look at this, larceny from auto, this is a crime date time, right? So this is a crime, like the count rate is occurring in which year, right? If we look at it here, it is peak at this time, then following this trend, then this, then again going up, right? If we look at this, in 2000, in the start of 2017, it was high, right? In 2018, this was okay. In 2019, it was again high, but 2 years again and going down. Little bit like the repeated over the time, the same pattern, but not every time. If we look at this time series seasonality here, so this is the US retail sales billions. This is given in the USD, right? Here we can see it started from here. It may be 1995. It started like this, right? So maybe this retail sale is going up on the holidays, like on the special days like Boxing Day, Cyber Monday Day, or other day when the retail sale is very high. But it is following the same pattern over the time. On the other side, it is increasing as well, right? But it is following some pattern over the time because it is showing the same spikes on over the time. It is not going like this much high, then down, then stable, then up, then down. It is over the time is same. So these kind of data set is known as seasonality. Okay. So this is the difference between the normal time series data and seasonality. When you have a seasonality data, you have a one very good option when you, if you want to look into in deeper way. We can decompose the time series into smaller components because it is a combination of seasonal component, overall trend, and the remaining fluctuations, right? How you can do that? You need to import the stats models tsa.api library, create the instance, and then you will say here use this method, seasonal underscore decompose. You will pass the entire data set in this, and then you will plot. Now look at these graphs. This is the first one. Again, the crime one. This is the original data, right? If anything is not clear here, what it will do, it will decompose it into 3 steps. The first step is it is showing the trend. Here how it is from the 2019 to 2021, or we can say till so here, right? November or October, it is showing the same trend, very high, right? And then it is going down. Then again up. So it is showing you the trend, right? And if we go here seasonal, here you can notice this is a seasonal, that this is a 0, right? And then it will start from here going up here, then again down, then again going up, down here. So this is following the same pattern over the time on each year. So this is called the seasonality, something which is repeated over the time, following the same pattern. And then what is left from this, when you remove, like as we have discussed the difference method and other methods, which will remove the seasonality and trend from your data set, then this is left with this residues. So it will show you the noise, right, in the data set, fluctuations. What is the fluctuations in the time series data set? This will only come when these both are not here. Okay, so this is not included, these two parts. This is called residues. So it will show you the noise, how much the noise in your data set. So this is the way how you can use the decomposition over the seasonality or pattern data set in the time series. Any questions about it? Okay. Okay, one question I have for you. Which have a seasonal component in this? A, B, C, and D. Okay, great. You can also answer multi-choice. It can be more than one. Great. Okay, thanks for sharing the answer. Everybody answered correct. C is the seasonal one. But if you look at these, the sales of new one family house, this is also showing some pattern, right? We can see same pattern it is following. Here it is down, up, right? So this is also the seasonal one, not these both, right? because this is, there is the, we have already, we can, if you look at these, this is 0, seasonality is already removed from here, right? Good one. Okay, so it,
Nisha, for the example that you just gave, so I mean, the seasonality is supposed to be inherent to like a specific industry or what have you. But like when you look at the change in the sales of the new family houses, you could argue that the fluctuation isn't so much due to the housing market, but because in the early 80s there was a recession in the United States, and the same thing with the downturn in the early 90s, and same thing with the 70s. So like, I mean, and for if what's causing the change is outside of that sector or industry, does it still count as that sector having seasonality? Because if it wasn't for the recession, you wouldn't see that change.
in this, like if there is a no recession, then there is a no change, right? But if we look at it, there can be a many reason. One reason is the recession, it can be the other reason as well. But maybe the, like if we take as an example, if we think as a layman, the people are like to buy the house, more looking for the houses maybe in some specific season, right? Maybe summer or the normal season, not they are looking for buying or shifting into the new houses in the winter season. Is it okay? Okay, so now we will jump on to the code along. First, I will cover up over the first lesson where I have left. It is opened in my local environment. So we will go to this first lesson first. So I left on that day. We covered the wide form series because we took the example of cryptocurrency in that. And here we also talked about the multi-index on that day, this one, right? And here we have a 3 type of how we resample it on the daily basis by setting frequency. And this is what we were plotting here, right? And then we will jump onto the, this one unstack. We did the unstack on that day because it was a multi-index. Now, this was a resampling which we take the from the year 2021 to 2022. Okay, so here from here we can start from the resampling. In this, first we will check the index. This is we set the index. Now we can look up for the weekly frequency. As we have discussed in the previous lesson, the frequency were weekly, monthly, quarterly, annually, and other one. In this, we are talking about the weekly, right? So here, if we set, this is showing you the plot for the weekly one. Okay, how you can set it. Now, if you want to apply the different frequency at a time on the data set, and you want to see the result based on different frequency, you can use like this way. So here we are making the list of different frequency, that is daily, weekly, monthly, quarterly, and annually. Then you will make up this for loop function. TS plot label original style, we are using this dot and dash. Then comparing resample data. Here we are plotting. You can see comparing resample data on daily basis. The blue line is for your daily basis, and original is your orange one, which we can't see here, right? This is like overcome the other one, override the orange one. Here we can see the weekly trend here, the line with the weekly frequency, this one. And here, this is the monthly one. So here, this I wanted to tell you all of, if you want to see, interested to apply the different frequency at a time on the entire data set. This is what you can, how you can use that. And how you can save this, the final data set, importing the operating system library here, folder. This is, you can make the folder and then you can save it. Okay. So we are just folder plus concatenating with this name, and then we are just saving this file name into this. Okay. So this is what I wanted to share. Any questions about this? All right. So let's jump for today's code along. Give me 1 second. Night is coming. So broad. All right. So now we will start with the UFU dataset, UFU site sinks. So in this, we are going to prepare here the irregular interval time series. In this, we will convert the date and time to single column if needed. These are the steps which we have like discussed already. This is, we are importing the libraries, and then we are loading the data set here. So this is your data set. This is your date time column and other columns coming in this. So now we will run these. This info of your data set. We have here date time, city, state, country, shape, duration, and comments, date posted. So we have 11 features in this. Now, first of all, we will prepare our data set here. So this is our first step, right? If needed, you can create a column. If don't required, we will change it into date and time. When we try to change here over date and time into using to_date_time, what will happen? It is throwing error here, right? So it is saying me hour must be in 023. It's showing 24 here. Like at some point, in some data points, the time period is coming 24, this one. Okay. Why this is throwing this error? Because this to_date and time function does not understand, is this the next day or the previous day? It is not recognized by this method. So if you want to fix this, if you want to change into the date time, how you can fix this, we will discuss later in this slide. Okay. So this is the reason when you see this error, because this method is not recognizing this. Okay. Either you set it 23, 59, or maybe 000 or 12. Okay. Now here, how do you handle the errors in time series? As you have learned about 3 ways, 3 parameter raise. This is raise an exception when errors happen. Ignores the error and returns the original value, right? It will ignore, just return the original value. There is no use of this using this parameter, right? What you will do if you have many missing value in that, or maybe data which is not correct, if it does not throw error, you will never come to know. It will not be a good model. Course, convert any bad time value to null value, no time. Okay, we use this. Now, here what we will do. Do you think we should course them, or what we need to do? First of all, we will check the missing value in the data set. How do you do that? First, we will see here the missing value in the date time 0, right? And here you have a missing value, right? Now, we will make one new column for the date time. We call it original. We will make a copy of the original one. We are not going to touch it. We will make it this one. So when you make this one, it will create the daytime original here. Okay, we are copying the daytime into this. So this is your data set with the new column daytime original. Now what you will do, we will create apply the course method error to handle it. Which error was occurring above due to the 24 hour, right? In that. So how would you do that? This is your new column you are creating with this course pd dot to date time UFO original comma errors this. What this method will do? Anybody what this method will do if I'm applying this?
Is it changing it to the right format?
Yes, right. Thanks, Daniel. It will changing into the correct form, right? So now look at the result. Again, we are checking the missing value. Look at the result now. What you can see. In the original, there was a 0 missing value, right? Now it is showing the null values in the course 694, right? So this means your data set contains kind of the date time stamp which is not convertible, right? So these converted into no time, NAT, right? So that's why it's showing this thing. If you want to look at the percentage, you can also use this method. This is just optional. I kept it here. Now we will look at these down here. Check only the course one. How many missing value? 694, 13 columns. What we will do now? We will just inspect these bad values now. We will create a bad rows variable here. Is NA, we will pass those values, 694 values of the course into this one. Now we will print the result. Now this is only showing the data points which contains the record where your course was not able to convert the original date time, or if it is not spotted, was not able to convert it into the correct form. This is the record. These are the only those data points. What we will do now again here. Now we will try to convert the bad rows again. Okay. We will use a try and accept method. In this, we will your time bad rows. We are only considering the bad rows, not entire data set right now. Daytime original, right? So it is throwing again the same error, right? Which you got earlier, which I showed you, 24-hour one. Now, how we are going to fix it? You can fix it because Panda is getting confused in 24, right? Is it the next day or what? Same day. So we will replace the 24 timestamp into 2359 using simple str.replace method. So this will help you, this method, to fix this error. Sorry, which was not fixed by your type of course raise error, right? So now when we replace this, now check the values again. Now again, we will convert this one, the date time fixed, because we have created a new column date time fixed, where we fixed this error 24-hour one using the string dot replace. We will convert it now to normal to underscore date time. Now it is not throwing any error. Look at the result. It is showing the result now. Okay. So you have this column. This is where you tried the course method to convert all date time stamp to date time, which did not work properly. Then this is your original, right? And you have a fixed one as well. No. This is the one. So this is what we want, right? So now what we will do, it's a time to check it again. Here the date time fixed contains 0, right? Now we will set the index because now we got the result what we wanted. We will set the index of the date time. This is set. After setting it, we can remove the date time field which is not required now anymore. So we will use this list comprehension method to remove it. If date time in C, then it will remove these all three. Okay, because we have already set the index now. Now it's like we will drop those columns. Our data set is ready here. We will check the index, right? Okay. So now what we did the little analysis with our data set. If this is error, how you can fix it, right? Using the course method and then which method you use. It's a time to now visualize it. So how would you visualize it? It's a simple. We will take this data set dot plot. Look at this. Is it making any sense? No, right? What we want to see in this, right? We can't analyze anything right now here. So how, if you have a time series data set, how would you decide what you want to visualize, right? Maybe you have a COVID data set, maybe you have a stock market data set, you have a finance data set. What you want, how would you decide which is important to display? How would you this? Sightseeing we data set, we want to show the duration of sightseeing and location, number of sightings, right? So how would you do that? Because this is like more important in this, right? Where the sightseeing taken, location, how many time, and what was the duration, right? So first we are just looking at the simple data set. Now getting our time series UFO sighting, how we can do? This is, I'm just making the demo copy for this one, the original data set. Now, if I want to see the number of the events occurred over the time, what I need to do? For this, I will make a one column that is count, which I will use later on to add the count, how many times that occurred those the sightseeing over the each interval, right? So what we will do, we will not touch the original one. We will make a copy of this into this, create a new column count. We will set it as is equal to 1. This is just for sake of default value. And here this is coming the count column. If you go down, you will resample and take the sum. Okay. So we are going to resample it on daily basis, right? We are going to take the sum of this. So it will show you the count of the events occurring within each interval on daily basis. Now look at the result. This is one method. Okay. If you want to see the sightseeing event within each interval. Other way, you can also use a size. It will also calculate the total number of events occurred on this date 1, this is 00, on this date 8 times and 13 and so on. So this is, you have a 2 options you can use. Okay. If you want to count the number of the events. Now what we will do here, we are again resampling this data with this size. This is a repetitive one, not required. Now we will plot the result. See the difference now. When we resample it on daily basis, it is much better than the previous one, right? After resampling, it is showing the occurring of the count of the each event over the time, right? But if you look at this portion, this is just nothing is happening here more, right? Much. So we can drop this, we can start from 1950. Okay. So now we will keep the location 1950 to above. So that's why we are using this 1950 column. Now this is the result. So this is showing you the like number of events occurring of the UFO sightings over the time within each interval using the resampling method on daily basis. Any questions still so far? Okay, very clear. Aggregating full data set using date parts. Okay, so how would you answer the questions to the stakeholder? If stakeholder is answering you, what month or year had the most sightings, right? How many sightings were there? Which month of the year has highest number of reporting sightings? Is there a seasonal pattern to UFO sightings? If so, how long is the season, right? And which US holiday has the largest number of sightings? So these are type of the questions may occur, right? According to the data set. So here we will make a one exploratory your EDA data frame for to answer these questions. We are not going to touch again the real one. We will reset the index again here for the UFO TS. This data set is ready to do EDA, feature engineering. So now first question was, what month or year had the most sightings? So in this, your daytime objects have these things, right? As we have discussed in the slides. So this is, we have written here. This is EDA year. We will get the year using EDA.dt dot month name. We will get the month name. Then the daytime, which day, day name and hour. Okay. Now we will look at the result. If we scroll here, this is showing your each year, each month, day of the month, a day of the week, and hour. Okay. Because you need to create it. You need to extract this feature if you want to answer those questions, right? Otherwise, how you will answer those questions? Now, let's add a weekend feature that will be true if the day was a Saturday and Sunday. Okay. Here what we will do, we will add the weekend. End of the day is in Saturday and Sunday. We are just checking. If this is the day of the week, Saturday or Sunday, then it will show the result. We can scroll on the right. Now this is the weekend. So it is telling you where it will be weekend, the specific, like at the data point, it will say true, otherwise it will be false. Okay. Now we will go down. Now we are just doing the here decade. We are just subtracting the remainder division by 10, which we have discussed in the slide as well. So this is the same method which I have discussed in the slide. So what is the result here? This, right? This is the decade. We are just subtracting the year from the previous one. Okay. And now we will come down. Now we will start answering the stakeholder questions. We will make our EDA here TS with the your that EDA1 data set. We will set the index because we have prepared the data with the extract feature to answer those questions. We have separated the month because we want to tell the stakeholder in which month more events of the sightings have occurred. Year, month, date, time, hour. Okay. Now we will set the index, copy this into the new data frame. Here we go. Now, what month, year had the most sightseeing? Again, we can use, if we are talking about monthly, you can resample it monthly and check the size, right? So it will show you this one. Right now in this, if you look at these, if we try to find out which month or what month contains the highest count of the sightings, you can use now TSIDX max. So it is showing 31st of July. Because we are talking about the month, it is taking the last date of the month here and telling you in this July 2013, the highest number of the sightings. So this is how you can calculate it and answer this question. Any questions still so far? Okay. Now we will look at this. What is the count of that? We know the month, but we want to know the count. So you can say TS dot location date most UFOs, which we have calculated here. It is showing 902. This is a count of how many times sightings has occurred in month of July in year 2013. Okay. Now you can also plot it. Here we are plotting TS plot, axis vertical line to see the difference, to highlight on the graph. Color is black. Here label is date most UFOs. Now look at this result here. This is showing here. This one. Okay. So this means in this year and month, this is the 902 count showing the most of the sightings happening. Okay. So this is you can highlight using axis vertical line. Now, which month of the year has the highest number of reported sightings? Okay. Now we can say we can do it using value count, right? In which month is like reported sightings. So it is showing the July here, 9520. Okay, highest number of the reported sightings in this month. The next question was, is there a seasonal pattern to UFO sightings? If so, how long? Right? A seasonal means repetitive trend is like occurring over the time, again and again. So here what we do, we will import statmodels.tsa.api as a TSA. Now TS check season is equals to TS.location 2000. Okay. So we can check out this location from this year and then see the result and then plot it. Check the season plot from 2000 year. It is showing over the time the same pattern. It is going 300, 400 maximum. This one over the year. After that, it's a high peak, right? But till so far, we can say it is following little bit same trend in these years. After that, it changed and start following this trend. Okay. So this is how we can get it the seasonal result of this. Okay. Check the season. If you want now, if this is a seasonality, you want to decompose it, you want to see the trend, you want to see the season and fluctuations. That is called residuals as well. Now, this is how would you do that? Decomposition, TSA seasonal underscore decomposition. This is the data frame which you get from above, which we have created here. Now decompose, plot it. This is your original data set. Here we cannot see the clear trend or like the seasonality noise. This is decomposed into three forms. This is trend. As we have seen little bit here, from this year to this, it seems to be same. This is showing same result here. From, we can say 2000, going like this, and then little up, and at the peak in 2013, we can say, or middle of this one. Then start following this trend. Here, this is seasonal, same, right? This is 0 at the center position, and this is the count, right? And after that, this is residue. This is showing the noise in the data over the time. Okay. So this is how you can decompose and check the seasonality, seasonal data set, different parts, trend, seasonal, and residues to understand the long-term time series to make sure you are on the right track. Like it is in my data set is following this trend. In this month, it was a high sales. Let's take an example of sales. At this time, this was a high sales, not in this month. When there is a extra noise, although there was a no sale in that month. Okay, so this will give you the clear picture. That we can, if you want, you can separate the seasonal component and plot as well separately. Here we are plotting it combined in using decompose method. Here you can separate it as well. Seasonal, decompose dot seasonal, seasonal dot plot. Now look at this result. Okay. So you have a very good options to look at your data into more detail of the time series. So you can also answer the questions of the stakeholders. After that, this is, we are using the SciPy peaks. This is good if you want to look at the specific peaks, you want to see how much peaks have in your data set. We will import this package, scipy.signal import find peaks. We will declare these two variables, find peaks, passing the seasonal data, height, seasonal max. Okay, so I need to run. Now it is showing the peaks at this point, at this count. And now this is setting index. Now, which US holiday has the largest number of sightings? On which holiday? So here, your Dojo environment, already we have installed the holiday package. If not, then you can just simply copy and paste this one and uncomment it. It will install that holiday package. Okay. If it throw error, import holidays, date time, holidays, import country underscore holidays library, and then country holidays US. So we will plot it. Now let's test a date. On 1st January 2015, what was that day? New Year Day. It is telling us, right? So now, if you want to map the like data frame to get all holidays in 1 year, right? How would you do that? This is, I'm using EDA data frame, which we have prepared earlier. EDA datetime dot map function you can use. Map is a very useful function in Python, which will automatically track the index of the dataset and print the result. Okay. US holidays.get, and then we are using the unique, so it will not be repetitive. It will show you the all holidays. Okay. After that, you can also count the holiday. Now it is showing Independence Day in total years, which we have a data set, 1208 times, New Year days, New Year Columbus Day, other days, how many times it is occurring. Okay. So now if you want to look at this is on this date, which movie was out. Okay. How would you do that? You will just give the date and then you can plot the sighting over the time, and you can also show the release date on the graph. Okay, so this is for that. Same using axis vertical line. Here it is showing 1995, 1997. Okay, so this is how you can use the different statistics method, your feature engineering methods, and how you can answer these stakeholder questions. Okay. Any questions till so far? I have a one breakout room activity. If you all are fine, no question, then we can move ahead with that. In this activity, all of you need to answer these questions. Which year had the highest percentage increase in sightings compared to previous year? Okay. And what day of the week has the highest reported sightings? Okay. We did it on monthly basis. Now you need to do it weekly basis. At what time of day hour do most sightings occur? Okay. Which US state has the most sightings? Which country had the largest proportion of sightings for the year 2000? Have the types and shapes of UFOs witnessed changed over a time? Okay. So you can only use the four most common shapes. Okay. In this, you can answer this question. I will open the breakout room. Okay. And this is the just bonus one if you are interested in this plot. This is Plotly, very good library. If you want to plot it, you can plot the your data in geo form using this. And you can also run this like this. It will start filling the values over the decade, the number of sightings like this. This is very useful. If all of you are interested, in Plotly, this is a kind of JavaScript, like the things using Python, but this is very useful in real time. When you want to create a visualization in Python, attractive, this is very useful at that time. You can get a code from here Plotly. If you Google the plotly.org, you will get it. There are many ways to plot this. Now, so I will open a breakout room. We share the Google, this one, your demo. This is a collab version of the exercise. Here all of you can answer the questions. These questions are here down. Okay, I will share in the chat. And later now, if you all are interested in the solution is inside the repositories under solution notebook. Okay, but try to solve it first. I will stop sharing.